Welcome to Band Protocol's Guide to Write Smart Contracts that utilize off-chain curated data. In this tutorial, we will explore how to query for real-time exchange rate between Ether and USD on-chain. At the end, you will be able to build and deploy a working smart contract. In this example scenario, you are an event organizer and plan to sell event ticket through the Ethereum blockchain. You would like to sell your ticket each for $10. You are a true Ethereum believer and has no trust in any stablecoins whatsoever. Thus, you would like your buyers to pay you in $10 worth Ether when buying a ticket. To do that, your ticket selling contract will ask the exchange rate between Ether and USD and compute how many WISE are worth $10. The smart contract requires the buyer to pass it at least that many WISE and return the excessive amount back. Let's start by exploring Band Governance Portal, available at app.coven.bandprotocol.com. Here you will find the set of curated datasets available on testnet. Let's head over to Financial Datasets. On this page, you will see the summary of the governance portal, which is outside the scope of this tutorial. Let's go explore data to see what Band has to offer. Here you will the list of data pairs available on crypto fiat. We have other categories as well, including ERC20 pairs, foreign exchange rates, and stock prices. Price information can be clicked to expand. This shows you the historical price changes of data reported from multiple sources into Band protocol. You can click on the key below to copy this key for later query. On the Integration tab, you will learn how to integrate Band protocol to your application. There are 3 steps. First, choose the key of data you would like to query. In this case, you can use ETH/USD key for getting Ether prices. After that, you declare Band protocol's query interface on your smart contract and instantiate the object with the address of the data set. We will copy it to the clipboard. Lastly, you can use the query object to obtain data on chain. Now let's head over to write our smart contract. First, we paste the address of the dataset that we just copied here. We start by declaring pragma solidity to specific eContract version. Next, we declare Band's query interface, which consists of 3 parts. The first part is query status enum. The second part is the query function, which takes an arbitrary length key and returns a triple of output, update time, and the query status. And the last function, query price, takes nothing, and return the cost of querying data. Once that is done, let's write our ticket seller contract. We declare constant ticket price value in USD to 10. We also declare a public mapping that tracks whether an address owns a ticket. Then we write 2 main function interfaces. Buy ticket is the public payable function to be called from ticket buyer, and get ETH/USD price times 10 to 18 is the internal function that magically returns the exchange rate. We will start by implementing buy ticket first. We demand that the caller must not already have a ticket, and he will have the ticket once the function call is complete. Next, we need to know the ticket price in terms of WAY, which is 10 to the 18 times the ticket price in USD divided by the Ether price in USD value. We require the buyer to pay at least the amount of ticket price in WAY. Additionally, if the buyer pays too much, we will return them the excessive amount of money. Okay, that's it for buy ticket function. For the function to get the exchange rate, we start by constructing the query interface object, which can be constructed using the address that we have already prepared above. Then we call query function. We are interested in query result and status. Note that we also pass in Ether equal to query price and use key ETH/USD for the exchange rate. We require that the query must be OK. If that succeeds, we return the output casted to an unsigned integer. And that's how we implement this function. That's it for the smart contract implementation. At this point, we are done writing code. Let's deploy our contract and test it out. Let's go to Deploy and Run tab. Choose Injected Web3 Environment and Ticket Seller Contract. Click Deploy to deploy the contract via MetaMask. After we wait for the transaction confirmation, once Etherscan picks it up, we can go to the contract page. We can read the contract's state. We can see that the ticket price is 10, and has ticket once we ask for our address, will return false, since no ticket has been purchased yet. Let's try to buy a ticket. We try to put in 0.01 Ether. Since the current Ethereum price is $223 each. 0.01 Ether is approximately $2. Notice that the transaction will fail since 2 is clearly less than 10. Now if we change to 0.05 Ether, which we know from doing calculation that it is greater than $10, we will be able to send the transaction to the network successfully. Let's follow the transaction to see how it goes. After the transaction is confirmed and Etherscan picks it up, you will see that the transaction contains 0.05 Ether sent to Ticket Seller Contract. Among the 0.05 Ether, 0.001 is sent to banned dataset as query fee, and approximately 0.00528 Ether gets returned back to the transaction originator. This means the total amount of Ether we paid was 0.005 subtracted by what we got back, which has the value of approximately $10 according to the exchange rate of $223 per Ether. Lastly, if we go back and check the smart contract, you will see that has ticket now returns true as we now have a ticket. That's it for the demo. We hope you enjoy it and learn more about banned protocol. Let us know if you have any question and happy building.